So, our new chapter, that is mechanical properties of solid. Mechanical properties of solid. What is the mechanical properties of solid that we will discuss. First of all, we discuss about the rigid body. In last class, in rotation chapter, we discuss about the rigid body. What is the rigid bodies? Rigid body क्या होता है? ठीक है, तो rigid bodies are bodies which shape and size are fixed. Which shape and size are fixed means their shape and size not change by application of external force. You know what is the rigid body? Rigid body. Rigid body are the bodies which shape and size are always remain constant. It will not change with application of external force. That is rigid body. But actually no such bodies exist. ऐसी कोई बॉडी एग्जिस्ट नहीं करती है. तो अगर हम प्रैक्टिकल लाइफ में देखें तो दैट इज नॉट पॉसिबल टू एग्जिस्ट ए रिजिड बॉडी. रिजिड बॉडी होना पॉसिबल नहीं है. तो हमारे पास जो हार्ड सब्सटेंस जिसको सॉलिड हम लोग बोलते हैं दैट वी विल कंसिडर एज ए रिजिड बॉडी. बट नाउ वी विल डिस्कस अबाउट द प्रॉपर्टी ऑफ द सॉलिड्स. तो सॉलिड्स आर solids or maybe liquid or gases, that are different thing. One thing that we will discuss here, that is elasticity, elastic nature of substance. We will discuss in this chapter mainly elasticity. 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 Before the elasticity, we will discuss about the deforming force. Deforming force. Deforming force. And one is restoring force. Restoring force. You know what is the deforming force? By the name it is clear. Name से clear हो रहा ना कि deforming force क्या होता है? Which deform the shape of any object. When we apply any external force on any object, that will responsible for the change the shape of the object. That is known as the deforming force. Deform means change करना. Deform का meaning क्या होता है? Change करना. तो force which is responsible for deform the shape of any object, that is known as deforming force. And restoring force. Restoring force is what? When we apply deform force, shape of the object will change. After some time we seen that in a spring, like a spring, when we stretch any spring, and after some time we feel that when we remove the deforming force, spring will regain its original shape again. Original shape regain करती है कि नहीं करती है? So this property, why they will regain? There will be some force inside the spring. There will be some force inside the spring that will responsible for regaining. Without force, that is not possible. So when we apply deforming force in any object, deforming force on any object, one force will generated in that object which will responsible for reshape of the object or regain of the same shape of the object, that is known as restoring force. If deforming force and restoring force both are same, deforming force and restoring both are same, in that case what happen? In that case what happen? deforming force and restoring force same. So object exactly get the same shape. Object exactly get the same shape. Okay. If these two are not same, that means object will not able to regain its original shape. If a object regain its same shape after removal of deforming force, if a object regain its original shape after removal of external force, that is known as elasticity, elastic nature. That is known as elastic nature. So any object which regain its original shape after removal of external force or deforming force, that substance is known as elastic substance, and this property is known as elasticity. This property is known as elasticity. So substances are two types. One is elastic substances and one is inelastic or plastic. So elastic substance, according to elasticity, we will define two type of substance: elastic substance, elastic substance, and another kind of substance, that is plastic substance. Elastic substance and plastic substance. Elastic substance are the substance which regain its original shape after removal of deforming force. Plastic substance which are not able to regain its original shape, that is known as the plastic substance. Clear? This thing is clear or not? Kuldeep, confirm? Okay. What is elastic? What is plastic? Now, you know, in elastic substance also have some limits. When we change again and again shape of any object, change again and again shape of any object, at the end it will lose the property of elasticity. It will lose the property of elasticity. So that is known as elastic fatigue. That is known as elastic fatigue. Elastic fatigue. Okay? What is elastic fatigue? When we regain the shape of any object again and again. Sorry, when we change the shape of object again and again, at the end it will lose the property of elasticity. This is known as elastic fatigue. This is known as elastic fatigue. Confirm? Now, one thing, when we change the shape of any elastic object, elastic substance, it will not regain its original shape. It will not regain its original shape just after just after removal of deforming force. It required some time. It required some time. So we are discussing about that any elastic substance required some time when deforming force is removed. So time required for elastic substance, that is known as elastic after time. That is known as elastic after time. Elastic after time. So time required for the elastic substance to regain its original shape after removal of external force, that is known as elastic after time. Got my point? कोई दिक्कत है इसमें? नहीं? पक्का? चलिए, तो नेक्स्ट हम लोग देखते हैं इसके अंदर one important thing that will start, that is stress and strain. Stress and strain. What is the stress? What is the strain? Stress is the restoring force generated in per unit area. When we apply deforming force, restoring force will generate. So restoring force generated in per unit area of substance, that is known as stress. That is known as stress. So stress equal to force upon area. What is the unit? Newton upon meter square. So it is same as pressure. It is same as pressure. Pressure we will consider in liquid or gases. Okay. And strain, it is the ratio of change in dimension. Change in dimension upon original dimension. Upon original dimension. So strain is change in dimension upon original dimension. It is unitless and dimensionless quantity. Unitless and dimensionless. There is no unit, there is no dimension. This thing is clear? Strain and stress. Stress is force generated, restoring force generated in per unit area, and strain, that is ratio of change in dimension to original dimension. Now this dimension may be length, may be area, may be volume. So according to that, we have type of strain. First type of strain, that is longitudinal strain. Longitudinal strain. So what is the longitudinal strain? It is the ratio of change in length to original length. It is the ratio of change in length to original length. So longitudinal strain, that is delta L upon L. Delta L upon L. Second, that is known as shear strain. Shear strain. So shear strain is known as, you can say simple area strain also, but actually area will not change. This will be like this. Understood from this diagram? This one, when we apply force here, then what happen? When we apply the force, you know, F is applied here, then these two sides, this will be rigid end. This is the rigid, ये यहाँ पे rigid है. Okay, this is rigid. So that upper face will be tilt. Upper face will be tilt in this direction like this. This side will be tilt by here. This one will be tilt by here. Okay, so same way this part will be tilted here. This part will be tilted here. So now when we compare, you will observe that this upper part is tilted. Okay. Shape will become like this. Shape will become like this. Okay. So here, this is the original line. This is the original line. And when we do like this one is the displacement of the tilting, like x. If this length of this side, that is L, and this is angular shifting, that is theta. That is theta. So can we say tan theta equal to perpendicular upon base, tan theta equal to x upon L. If theta is very small, then theta equal to tan theta. Tan theta nearby equal to क्या हो जाएगा? Theta. So theta equal to x upon L. X upon L. So shear strain is nothing but theta. Nothing but theta, or we simply say it is tan theta, or it is x by L. It is also unitless and dimensionless. इसकी भी कोई यूनिट नहीं होगी, कोई डायमेंशन नहीं होगा. Clear this one? Now, next one is volume strain. Next one is volume strain. So what is the volume strain? You know about the volume strain? That is change in volume upon original volume. Or normally we use minus delta V upon V, because by application of external force, volume of the substance will generally decrease. Generally decrease. When we change the length will increase. Length will increase. Okay. So according to these three, we have three kind of stress also. So first one is longitudinal stress. Longitudinal stress. So what is the longitudinal stress? What is the longitudinal stress? Stress responsible for change in length of object, which is responsible for change in length of object, responsible for change in length. जो लेंथ में चेंज करता है, that is longitudinal stress. What is the shear stress? Which change the shape of object? Which change shape of object. Okay. And next is volume stress. Volume stress. So volume stress is which change volume of object. जो ऑब्जेक्ट के वॉल्यूम को चेंज करता है, दैट इज नोन एज वॉल्यूम स्ट्रेस. उसको क्या बोलेंगे हम लोग? वॉल्यूम स्ट्रेन. सो दिस थिंग इज क्लियर अप टू हियर और नॉट? व्हाट इज द स्ट्रेन, व्हाट इज द इलास्टिक substance, what is the inelastic or plastic substance, what is the stress, what is the strain, type of strain, type of stress, elastic after time, elastic fatigue. Got it or not? Okay, so that's all for this lecture. We will discuss next part, Hooke's law, Young modulus of elasticity, shear modulus of elasticity, volume modulus of elasticity, energy stored in elastic substance in next lecture. Okay, got it?